All right, you got these? Let me move it up some. Are we good on this page? Alright, let's look at page 2 really quickly. If you didn't get it at all, just take a picture of it and then copy it down later, or this video is going to go on YouTube so you can look at it later. We have a lot to talk about today. A lot. But if you have a question, I mean, we can talk about questions. But if you're starting from scratch, we ain't got time for that. Still can't see that. All right, good. Okay. See that? It's like a pro. Alright, you have this sideways page, that's where we are today. Alright, so in calculus, the result of the integral of f of x dx is a function that represents the antiderivative of the function f of x. It's sometimes referred to as an indefinite integral. Okay. Now, see how this one is different from that one? Okay, when you put these little boundaries on it, right here, from A to B, that represents the area of a region bounded by the curve f of x on the interval from A to B. See, so just notice those differences, okay? Calculating Riemann sums is a way to estimate the area under the curve. The value of the integral from a to b of f of x dx for a graphed function on a particular interval. So we're going to look at 4 of these types of Riemann sums: left hand, right hand, midpoint, and trapezoidal. I don't think we'll get them all done today, but we'll at least try and get through it as much as we can. Alright, so we're going to go with the left hand with intervals of a length of 2 units. And what we're finding, let me say this one more time, is we're going to be estimating the area under this curve. Okay, that's what we're going to be estimating, the area under this curve. And so we've got f of x equals a negative 1/3 x squared plus 2x plus 5. And we want to go on the interval from 1 to 7. 1 to 7. And we're going to subdivide the area of the graph, the function and the x-axis into rectangles with a length of 2 units. Okay? So, where's my good pencil? Here it is. Make sure, since this is a left-hand sum, we're going to place the upper left-hand vertex of the rectangle on the curve. Then we're going to calculate the area. So let's just see how that looks. First of all, let's see what the drawing looks like. Okay. We're going from 1 over here to 7. That's the area that we're looking at. Okay, that's our interval from 1 to 7. We've got these points here. We're going to use these points. We're going to start right here with this one. How wide did he say the rectangle needed to be? 2 units. So the left hand is right there. It's going to go over 2. And this right here is one of my rectangles. Now that goes to here. So I need another rectangle that starts right here and goes out 2. I'm going to make this rectangle go this way so they don't look like they're all the same rectangle. Thank you. My next one's going to be right here. It's going to go out 2. And I guess we can go back this way again so you can see where the rectangle is. There we go. Alright, now, how do you find the area of a rectangle? Length times width, right? That's pretty easy. So we know the length of each of these. What's the length? 2 of each of these. How about the width? How about, or the base times height? We know the base is 2. How about the height? I see I saw your mouth was moving, but I don't know if anything. Probably what we're gonna find. Well, how can we find it? Like, can I find this point right here? It's on the curve, right?
Wait, we have a function.
We have a function for it. You're right. We have a function for it.
All you have for x value, so you can just plug it in.
Right. I have a function. I have an x value, so I can just plug it in, right? So remember this, the estimate of this area is the integral 1 to 7 of f of x dx, and it's going to be about, well, let's do this rectangle. That's 2 times f of what? 1. Plus this one, which is 2 times f of, where did that one start? Right here at 3. Plus 2 times f of, what's the last one? Right here. So that one's f of 5. Or you could just say 2 times f of 1 plus f of 3 plus f of 5. Alright, that's math you can do. I'm going to wait while you do that math. You can do it on your calculator. You have it? Chris, you gotta find your calculator.
It's right here.
Oh, that's your phone.
It has a calculator on it.
What'd you get?
42.66 units squared.
3 decimal places.
666 or 667.
667. 42.667 square units. All right. All right. Did everybody see how we did that? What all those, where all these numbers came from and all that?
Yeah.
Okay. So let's use the same shape. This time let's do 1 unit.
And so that was the area.
Mm-hmm.
Okay.
That's the area. That's the approximate area under that curve. So now let's just do it with 1 unit. Still from 1 to 7. So I'm going to start here, and that's one of my rectangles. And here's a rectangle. Here's a rectangle. So now this one is going to be about, what's the base on this one? 1 times f of 1 plus f of 2 plus f of 3 plus f of 4, f of 5. I'm out of room. Oh, I went all the way to 8, and we're ending at 7, so I don't know what I was doing there. At 2, 3, 4, at 5, and then at 6.
Is this the same equation?
Mm-hmm. On the smartboard, I can pause recording when we're working so people don't have to sit while we work. I can't pause recording on this. Like, it's, you start and you stop, and then when you start again, it's a new video. So, sorry, Paul Ray, you're just going to have to sit, well, or you could fast forward while we work. And there's a lot of work. Are you using your table on your calculator to get these numbers, or are you typing this in every single time? You're using the table? Yeah, because it's much faster, you know, right? Well, I noticed he's finished, and like, look, if you put this into your y equals, and then you use your table, it gives you the value, and then you can just, you know, use those to sum it up if you need to. Save yourself some time. Time is precious. Precious, precious. So what'd you get on this one?
44.33.
Say that again for me.
What was that? 44.33.
That's not what I got.
41.667.
That's what I got. I got 41.667.
I probably hit a wrong number.
On the table,
Uh-huh.
f of 3 says it's 10, not 8. So I don't know if that would,
On your table it says it's 10?
yeah.
Alright, let me make sure. I've got negative 1/3 x squared plus 2x plus 5. Is that what you have for your y equals?
I don't know why we got that number and they didn't.
Yeah, I got 8 for some reason too.
I got 8 on my table.
That's what I got when I put that in like
Oh,
this.
okay.
But that's not what's on your table. Like when you type it in, you get 8, but on your table you're not getting
I
it.
think I
Is there
put-
something else in your calculator? Because that can,
Yeah, I think so.
so you might want to check that too.
I think I put my points.
You're going to want to use this because, alright, look at this one. Same thing again, but now what's going to happen?
A lot more rectangles.
A lot more what?
Rectangles.
A lot more rectangles, yeah. We've got one here and here. One here and here. Whole bunch more rectangles. I'm not filling those in because that takes me like a year just to fill it in. So you're now looking at, I'm going to have to write a lot smaller. The antiderivative of f of x dx from 1 to 7 is about, now what's the base this time? 1/2 times f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 all the way to f of 6.5. The last rectangle starts at 6.5. It ends at 7.
Alright.
So I just changed my table to go by 0.5s so I can sum that up more easily. Do you know how to change your table to go by 0.5s instead of going by 1s? When you first open your table, hit the plus sign. And does it say what you want to change it to? Okay. So that should help you out. Gosh, if there's only a way to do these more quickly.
I feel like you're going to tell us how you're doing this.
Maybe, I don't know. I might at some point show you a different way. I don't know. I guess it depends. What'd you come up with?
40.9.
918? I got 917.
Yeah, that's what that was.
I don't know. When I was, I rounded up some stuff, so that might be.
Not yet. Alright. Now we're going to change things up. Now we're going to do a right hand sum. Okay? So this time, the upper right hand vertex of the rectangle is going to be on the graph, on the curve. We're going to start with a length of 2. We're still going from 1 to 7. Alright, so this time, this is our corner, okay, and it goes this way. Now this one's our next one, right here, and it goes back this way. And then this one right here is our last one. It's right here. Now, this process down here, it's kind of the same. We're still looking from 1 to 7 for f of x dx. Our base is 2, but our corners that are touching the graph, those are different numbers now. Now I'm going to look at f of 3 and f of 5 and f of 7. See what you get for that area. Christian, what'd you get?
34.667 units squared.
All right, 34.667. Let's do a 1 length over here. It's going to start here. And we got one here. What'd you get?
37.667.
Mm-hmm. All right. All right, do the right hand with a half unit. Well, you're wanting to go to the right, so you're going to start at 1.5 and go off to the right, because that gets you, whoops, you can draw a rectangle. Apparently I can't. And then from 2 to 1.5, and then at 2.5 over to 2, and then 3 over, 3.5 over, it's beautiful. You'll have to let me know if it's not showing.
Oh, I had my head down.
I know. This poor Paul Ray, he won't know anything about this. I tried to watch the videos, it was a blank screen. What'd you get for this? Did you get this already?
Yeah, 38.917.
Yes, 38.917. Alright, so before we continue, what inference can you make about the approximations as the lengths of the rectangles decrease?
Approximation.
Yeah, as the lengths of the rectangles get smaller, the more accurate your estimation is. Right. Alright, so graphically, why do you think this is happening? Why do you suppose this is so?
Maybe more points to go by. So, I don't know how to explain it.
Look on the graph. What's happening on the graph the smaller you get those rectangles?
It better goes the inside.
Okay, it fits better?
With less of it going on the outside of the curve.
Okay.
How did you say that?
Fills it.
It fills it better?
Yeah.
Okay. Yeah, well there's less of like an overage
Yeah.
or an underage. Yeah, that's right. So when you get those rectangles smaller, it fits better. Like you both said, it's a better fit. There's less leftovers. There's less leftover on the outside. There's less gaps on the inside. So all that's true. All that's true. You can pick however you want to write it so that when you're looking at it later you're going to understand. But it just the smaller you get those rectangles, the better it fits that curve. Yeah, no, that's not it. Let's try to get through the midpoint before the bell rings. We've got like 8 minutes left. I think we can get through midpoint. Alright, so we're going to do midpoint sum. So we're going to draw our rectangles. So that the upper right hand vertex of the rectangle is on the curve. So no, so that the midpoint is on the curve. So the first one we're doing 2 units. Again, so if I'm doing 2 units, here's 2 units, and this is the midpoint, so the rectangle is going to look like this right here. That's my first rectangle. See it right there? My second rectangle also midpoint. Looks like those are the same height. Could be verified pretty easily. So it goes right there. And then here's my third rectangle. What's the base? 2. And for my first one, that's f of what? How high is that? F of 2, because that's where my rectangle intersects the graph. So this one is f of, what is that one? F of 4, and then f of 6, right. I think we could probably get these finished. I don't think we'll have time for a trapezoid today. We'll have to do trapezoids tomorrow. What'd you get?
667.
Alright. Let's do midpoint over here. And this time we're only doing 1 unit with a midpoint. So, like right here, 1.5 is my first. And then 2.5 is my second. What's my first function? F of what?
1.5.
And then 2.5. And 3.5. I'm going to run out of room. All the way to 6.5. It's my last one. What's your sum?
40.167.
Yeah. 40.167. Just really quickly, I just want to look at the trapezoid. What time is it? Yeah. Super quick. I may let you struggle with this one for homework. Alright, so remember for a trapezoidal, or for a trapezoid, the area is 1/2 base 1 plus base 2 times your height. Okay? Base 1 and base 2 are parallel sides, and h is the distance between those two sides. So if we're trying to do a trapezoidal sum here with interval lengths of 2 units, then that we have to draw it like from 1 to 3. We draw a trapezoid from 1 up to 3. We draw a trapezoid. And then from 3 to 5, we put in a trapezoid. From 5 down to 7, we have a trapezoid. So that's going to be 1/2 times the height. The height of each of these is 2. Now we have times base 1 plus base 2. Okay, well, for this base 1 plus base 2 is f of 1 plus f of 3. Well, for this one, base 1 plus base 2 is what?
F of 3 plus f of 5.
Mm-hmm. For this one, base 1 plus base 2 is or you could have 1/2 times 2, which what happens to 1/2 times 2? Yeah, those are going to go away. So I have f of 1 plus 2 f of 3's plus 2 f of 5's plus 1 f of 7. That's what we're looking at right there. You think this one's going to be more or less accurate than the others? More. Why?
It never leaves the perimeter of the curve.
Right, and there's very little wasted space. Alright, go ahead and figure that one out, and we'll talk more about these tomorrow.